You're going to need a few things to follow this tutorial. Number 1. Rooms built inside Unreal Engine. As you can see here, I just dragged in a basic cube, scaled it by 3 in the X and Y axis, but the size doesn't matter if it's a perfect cube room, and then rearranged them to form the floor, ceiling, and walls of the room. I did all of this in a separate level called L_room generator. I'd also suggest putting a cube above the room which is scaled up big enough to block any lighting from the level, as well as deleting the skylight component if you have one in your scene. This is because light could pass through the seams around the room and we don't want that. Then I just added a point light to the center of the room's interior. You can go to the top right of the viewport and click on the 4 cubes to help you line up the light easier. When you're done with lining up the light, you can click on the big rectangle in the bottom left viewport to expand the viewport to its old size. Number 2. Textures. The textures I used came from Ambient CG and they are completely free. Now that I have the textures, I'm going to apply them to the cubes used in our room. All my textures are saved in the folder called Rooms. I'll go ahead and drag the materials I want to use on the cubes. Number 3. Furniture assets. The furniture pack I used is currently on screen. It's completely free as well. Number 4. A noise texture. The noise texture used in this tutorial was made by me and I'm giving it away for free. In fact, all the assets listed on screen, including my noise texture, will be in the description. Now that we have a basic room, we can go ahead and capture a cube map. We'll go to the top left, click on create, hover on mouse on all classes, and type in cube. We're going to drag in the scene capture cube, and then we're going to go ahead and align it to the center of our room. So if I go ahead, move the camera here, here, and then the center in our room. I can go ahead and maximize that viewport again. Now this camera component will go ahead and create a cube map, but before it can even create a cube map, it needs something to capture to. So we'll go to the details panel, under scene capture, and next to texture target, we're going to click on none, and we're going to click on cube render target to create a new one. I'm going to call this CRT for cube render target and then room 1. You should notice a reduction in your viewport performance. To fix that, you want to go to the details panel and untick capture every frame. This means every time we want this camera to update, we just want to move it up and down so that it updates. While we're here, let's go look at our cube render target. I'm going to open up my content browser, go to my content folder, and open up CRT Room 1. This is how our cube map looks, but currently we're not going to adjust anything with the settings, but we will when we actually add our furniture. So we're just going to go ahead and close out of this window. This is the part in the video where you create multiple rooms. To easily do that, you just want to click on your scene capture cube, go ahead and turn off capture on movement because we're going to duplicate everything and we don't want it to recapture that cube map. We're going to go ahead, shift click to select everything in the room, just select all these, and also go ahead and select the light in the center of the room, and also select this cube at the top that's blocking the light, and hold Alt on your keyboard and drag out to create a duplicate. Then you want to go to your scene capture cube, go ahead and click on CRT Room 1, create new asset cube render target, and then we're going to call this CRT Room 2. Now that we have a new room to apply textures to, we can go ahead, open up a content folder, Rooms, Room 2, and apply bricks to all the new walls. You can use any texture you want. I just went for different bricks. And then I'm going to apply M tiles here. And then yeah, this is the new room. And of course we want to click on our scene capture cube, turn on capture on movement again, and then you just want to move the camera up and down to force an update to the cube map. And then we can go back to our content folder, go to CRT Room 2, and now you can see how our new cube map looks. Now I'm going to go ahead and create multiple rooms off screen, but because we have 2 rooms, we can already go ahead and set up our basic shader. So let's go ahead and do that. Firstly, we want to close out of the CRT Room 2, we want to open up our content browser, we want to right click, create new material, and we're going to call this interior shader. Going to just go ahead and capitalize the I, press enter, and now we can go ahead and open that up, and I'm going to dock this to the editor window. Now before we go ahead and use noise textures to blend multiple rooms together, let's create the basic cube mapping shader. We're going to go ahead, move a bit to the left, right click, and type in interior cube map. This is a material function inside Unreal Engine specifically for interior mapping, and it uses cube maps. That's why we're using cube maps, because there's already a lot of code inside Unreal Engine to make the shader a lot easier. So let's talk about the inputs and the outputs. The first input we care about is tiling. It takes in a vector 2, and while tiling would usually mean how much this texture is repeated, this just means how many rooms should be to the side and to the top of the building. We can adjust this based on what building we're working with. So this means that if you're working with a small building, we can use less tiling, but if we work with a bigger building, we can use more tiling. And then there's randomize rotation, which takes in a boolean. If this is set to true, this will actually rotate the cube map in 4 ways to show the front, back, left, or right side of the cube map. And then we have the UVW output. This will be plugged into the cube map, and this is how Unreal Engine tells the cube map how to scale and change itself so it looks like a normal cube room. That's really all there is to this. So let's go ahead and go add our cube map to work with. Now we can just go ahead and open up our content browser and drag in one of our cube render targets. If your content browser didn't open, just close and open the material again. Then it should work. Now we're going to go ahead and drag in our CRT room 1. Plug the UVW in the UVs, and plug in the RGB into the base color. And now in the preview window, we're going to set the preview mesh to a cube primitive. And now you can already see our rooms working. Now that we have our basic shader up and running, let's go ahead and add some parameters so that we don't have to recompile every time we make a simple change. So here at the left side next to the interior cube map, we're going to right click, or actually you can hold S on your keyboard and left click to create a scalar parameter. We're going to change this to interior mapping X tiling, and then you can go ahead and duplicate this, but then you can go ahead and call this Y tiling instead of X tiling. And we could go ahead, let's set these by default to something like 10 and 10 respectively. And we can go ahead and in the group section under material expression, you can go ahead and type in texture settings, or you can call it general settings as well, and go to your interior mapping X tiling and set that as well. And now to make these a vector 2, we can go ahead, right click, type in append vector, and if we go ahead, plug A into the X and plug Y into the B, and we can go ahead and plug that append into the tiling, and now we have adjustable tiling without having to recompile everything. So if I change the value to 9, 10, 1, 10, 15, we don't have to recompile, and it's perfect for our material instances later on. So I'm just going to set that back to 10, and this is everything set up. We can also go ahead and set this randomize rotation, or create a parameter for that. We can right click on randomize rotation and promote to parameter. Gonna move this down here. And we're also gonna go ahead and remove the B in the randomize rotation name, and then the group we're gonna go ahead and set to actually we can set that to the same as the scalar parameters, so we can set that to texture settings. And yeah, that's all the parameters we have to worry about now. Now we have our basic shader up and running. There's something we need to tackle, and that's furniture. Now we're going to add furniture to our rooms. Now I already know there's gonna be a problem when we add furniture to our rooms, but I'd rather let us make this mistake, and then I can show you how we're gonna fix this mistake, rather than just tell you what's the problem with cube maps. So let's go to LCube map generator and add furniture to our room. I'm going to open up my content browser, open the furniture pack I downloaded, and go to meshes. Then I'm going to go ahead and add a few meshes to my room. I'm going to time lapse this because this is pretty boring. Okay, now that we filled up our room with furniture, we can move the camera up and down to force an update and go to our interior shader, and we can see there's a lot of problems. And it's pretty simple why we're facing this problem. Furniture is a 3D object, but a cube map can't hold 3D information. What do I mean with that? Well, see, a cube map is a 3D image by nature. It's 6 images mixed into one to make a 3D cube. But nothing inside of that cube will ever be 3D, because that's out of the scope of a cube map. So for us to make this furniture work, we need to, of course, based on what furniture is, if it's a roof light, we have to squash it against the roof. If it's supposed to be on the walls, we need to squash it onto the walls. And if it's something like a rug, we need to squash it onto the floor. So we're going to adjust the scaling so that it not clips into the wall, but at least is very flat objects. So that's a limitation with the shader, is that there won't be any 3D furniture. But to be honest, a lot of interior mapping shaders I've seen don't have interior furniture, and the others that do are pretty advanced. So what we want to do is we want to flatten our furniture so that it looks like flat objects. We can easily do that by pressing R on our keyboard and scaling this couch on the y-axis. Now this scaling isn't too great because it's still too thick for our needs. So we're going to go to right side, go to details panel and type in 0.05. Most of the assets work with 0.05, but some bigger assets like the bed require 0.03. Now that we have our scaling correct, we can try to move it as close to the wall as possible, but we're quickly going to hit a snag because it's going to clip into the wall. We want to go to the top right of the viewport, click this grid icon, and move this couch as close to the wall as possible, then turn on grid snapping again so we can move this camera up and down into a perfect spot so we can update the camera. Now if we go to our interior shader, you can see the couch looks in a way better state than the table does. You just want to flatten every single thing in every room until it's flat against the wall. Don't be too scared that it's too flat. It's better to have it too flat than too thick, because too thick will definitely break the illusion. You might want to change the resolution of your cube maps. You can quite easily do that by opening up your content browser, opening Cube Render Target, and setting the size to a higher value. I'd recommend max 512 because anything over that could use quite a lot of VRAM. You can just hit save and then quickly move your camera up and down to force an update. And now you can go back to your Cube Render Target and see that it's a higher resolution. One more thing you definitely want to do, you want to go ahead, open up your content browser, right click on your Cube Render Target, and create static texture. This creates a static version of this real-time texture that doesn't change no matter what you do with the camera. We're going to rename it now by right-clicking, rename, and we're going to rename this to STC for static texture cube. You definitely want to do this with every single cube map you're done with. If you want to change a cube map but still use a static texture, you can just go ahead, delete the static texture, and go ahead, right click, and create another static texture. That's really all you need to know, so I'm going to go ahead and furnish a couple of rooms off camera. So here I have a basic demo scene. It's just a few cubes scaled up. Later on there will be skyscrapers, but currently we don't have our material ready, so these aren't anything yet. And also, here I have a folder, in my content folder, cube maps, static textures, and this is where I saved all 11 of my cube maps. Now that we have all these cube maps, we can actually go ahead and create a material function to handle our noise. I'd love to explain how this material function works, but it's way easier to explain once we're finished with it. So to create it, we're going to go to our content folder, we're going to right click, we're going to go to materials and textures, we're going to click on material function. We're going to call this MF noise blend. And now we can go ahead and open it up. And I'm also going to go ahead and dock the editor window. If you haven't imported your noise textures yet, now is a pretty good time. If I open up my content browser, you can see I have a 128 and 1024 noise texture. Currently, we'll be using the noise texture 128. This texture will be the noise texture for our lerp. The problem with it now currently, it's using the entire texture when we only want a small part of this texture. So let's go ahead and extract a small part of this texture. We're going to go to the left of the screen, right click and create a new texture coordinates, and then I'm going to go ahead and enter that. We're going to do math after this texture coordinate, so we're going to leave the U and V tiling on its default of 1. We want to go ahead and divide this texture coordinate by dragging off its pin, typing in divide, and then plugging the end result into the UVs. This divide will be used to break up the pixels individually, so this means we need to set the divide to the amount of pixels of the texture. So we're going to go ahead and set this on 128 because our texture is 128 by 128. Of course, this will only display 1 pixel at a time, so we want to expand this by going to our texture chord, dragging off it, and creating a new multiply node, and then plugging in the result into A. What this multiply will do is it will actually adjust the size of the texture based on how many rooms are in the current building. So before we add parameters to both of these, we can just move up the multiply and move up the divide, move them a bit closer to the UVs just to clean up our graph a bit. Let's go ahead and add a couple of function inputs so we have parameters to play around with. We can right click in the open and type in function input. We're going to go to the bottom left details panel and change the function input vector 3 to function input vector 2. And we're going to go ahead and plug in the output into the multiply. This input will take in our interior mapping tiling X and Y inputs so that it knows how big to scale up this texture. That's really all the inputs we care about here, but if you want, you can add in the texture inputs if you want random noise textures for every single layer of lerp. With me talking a lot about lerp, you might already understand how we're gonna mix multiple rooms together and randomize them. If you haven't figured it out yet, we're going to use the lerp node to mix multiple rooms together, but then lerp them with a noise texture in a different position of this noise texture. Each pixel of this noise texture is black or white. This means the black pixels will stay the same in the lerp, but the white pixels will be used to overwrite with another texture in the lerp. By lerping multiple rooms with multiple variances of this noise texture, we can create different variations for our building. If you don't understand it now, don't worry, when we go back to our M interior shader, you'll understand it. So now that we have the rundown of what we're going to do, let's go ahead and implement it in our M interior shader. But before I do that, I'm going to rename my inputs in. If I click on it and change the input name, I can change it into interior mapping tiling, so we know that this is where the tiling will plug in from the M interior shader. Now that I have that done, I can go ahead and go to the top left, click on save, and it will automatically apply. If it didn't, just click on apply, and now we can go ahead and go back to our M interior shader. Now let's go ahead and add in the new material function. I'm going to open up my content browser and drag in MF noise blend. I'm going to position this a bit down because we need to leave a bit of space open for a lerp. Talking about lerp, let's go ahead and add a lerp node. I'm going to right click in the open and type in linear interpolate. The A value is going to be our first texture sampler, and the B value is going to be a new texture we're gonna lerp with. I'm going to go ahead and open up my content browser, go to Cube Maps, Static Textures, and drag in a new room. I'm going to plug the RGB value into B, and then the alpha is going to be the result of our noise blend. I'm going to plug in our append node from this interior mapping X tiling and Y tiling into the interior mapping vector 2. Now I'm going to plug in the end result into the base color. It's going to throw out an error because we haven't assigned our interior cube map function to this texture. You can fix that by plugging in your UVW from your interior cube map into the UV of your new texture sampler. Now we can move a few stuff around just to make this look a bit cleaner. Now our nodes look a bit cleaner, let's go ahead and increase our interior map in X and Y tiling so we can see a bit of the randomization. I'm going to put both of them at a value of 10. If I go to my preview window and click on the cube, you can see that the randomization is working. There are currently two problems. One is very apparent and the other one will be apparent later on. The first problem is you can see a bit of the rooms blending into each other. The reason for this is because we're sampling a texture based on perfect pixel values, but Unreal Engine actually has filtering on by default, which means that these pixels we're trying to sample as a pixel per room are actually blurred. We can easily fix that by opening up our content browser, going to our noise texture 128, clicking on the drop down on the texture, and just setting the filter mode from default from texture group to nearest. You can go ahead and save that and go back to your M interior shader. It's still going to look the same, so you can press any preview icon you want and go back to the cube, and now it's fixed. We can go ahead and clean up our graph one more time so it's easier to add lerp layers. We'll start off by selecting both of the texture samplers we currently have and changing their sampler source from texture asset to shared wrap, so they all use the same texture sampler. We can also convert these texture samplers into parameters, so we can easily change them in our material instance. Let's right click on the first texture sampler and click on convert to parameter. We're going to call this room 1. We can also do the same for the second texture sampler. Click on that, convert to parameter, but instead we'll call this room 2. We can also go ahead and group these in their own material groups. We're going to click on room 2 and change the group to room 2. We can also click on the first param and change that to room 1. And now they both have their own group. This means every time we want to blend in a new room, we can just select one of these rooms, press Ctrl W, and go ahead easily rename it to room 3. And you can also change the group to room 3. And that's perfect. You just do this as many rooms as you possibly want to, and that's just really the basic setup. You can also go ahead and click on room 3 again, scroll all the way down, and then adjust the texture to a new room. Now we can go to the top right and press Ctrl W on the slurp, so we create a new one. The A value will be the previous slurp, and the B value will be the new texture. And then the alpha will be a new noise blend copy. So we're going to click on the material function and Ctrl W to duplicate. We're going to plug in the results into the alpha, and the interior mapping tiling input will be our append node. And also, before we forget, we want to plug in our interior cube map, UVW, into the UV of the new room. And then we can plug the final lerp result into base color. This leaves us with a problem because we're using the same noise texture and not offsetting the values. This means that every lerp after the first lerp is just going to replace the previous rooms because it's using the same noise texture with no positional difference. We can fix that by adding offsets to our noise texture. So let's go back to our MF noise blend and add an offset input. Now that we're here, we can go ahead and add a new input for our noise texture offset. We're going to go to the left, right click, and type in function input. We're going to change the input name to noise texture offset. While we're here, we're also going to change the input from vector 3 to vector 2. Now what we're going to do is we're going to go ahead and add our noise texture offset to the texture coordinate, so we can offset the texture for every single lerp we do. We can easily do that by dragging off the texture coordinate and type in an add. And then the noise texture offset vector 2 is the B value, and the end result goes into the next multiply. That's all we're gonna need here, so we can go ahead, save, and apply, and Unreal Engine will automatically throw us back into our M interior shader because it knows we're missing inputs for our material function now. Let's go ahead and add a few scalar parameters for these material functions. Let's go ahead and create a few scalar parameters for these offsets. We're going to go ahead and take these two scalar parameters and Ctrl W to duplicate. I'm going to go ahead and rename these. I don't want it to be named interior mapping, I want it to be named noise texture offset. And I'm also going to remove tiling at the end, but replace it with the room we're currently on. I'm going to use this for room 2 now, so I'm going to change the name to room 2. Now I can copy this name and use it for the bottom one. So if I double click and open the bottom one and replace the name with offset X, I can just go ahead and change the X to Y. And now we have new scalar parameters. I'm now going to go ahead and duplicate the append node here at the top so that we can append both of these into a vector too. I'm going to plug the top one into A and the bottom one into B, and then plug the end result in our noise texture offset. I'm going to go ahead and click on both of these and change their group from texture settings to room 2, because they're currently a part of the noise blend of room 2. Now of course the material isn't going to work yet. We need to go ahead and duplicate these noise texture offset scalar parameters and plug them into the noise texture offset of room 3. And while we're here, we can go ahead and click on both of these scalar parameters and change them to room 3. So here on the top one, now it's offset room 3, and then I'm going to go to the bottom one and set it to offset room 3. And while we're here, we can also go ahead and change their group from room 2 to room 3, and here the top one, room 2 to room 3. And now we just do that for every single noise texture we add further on. Now of course this isn't going to work because both of these offsets are using the same values. We need to go ahead and create a new value for one of these offsets. So I'm going to click on offset X room 3 and change the value from 10 to 20. Then I'm going to click on the Y room 3 and set the value to something like 5. Now if I go to the preview window and click on the cube, you can see we're blending across multiple rooms now. Now let's go ahead and add one more quality of life improvement. We're going to go to the top right to the ellipse and right click. Then we're going to go ahead and type in static, and we're also going to go ahead and click on the static switch parameter. This means we can turn off certain blends with booleans. I'm going to go ahead and rename this parameter to blend with room 2 with a question mark. If we're blending with room 2, we should use our lerp into the true. But if we're not blending with room 2, we should use our original cube map. Let's move our lerp down a bit and move our blend with room 2 to clean it up a bit. Now we can duplicate this blend with room 2, but instead of it being blend with room 2, we just rename it to room 3. If we blend with room 3, we should use our lerp, but if we're not blending with room 3, we should use our previous blend with room 2, and now we can plug in the final result into the base color. Let's also group these in their own groups. We're going to go to blend with room 2 and group it into the room 2 group. And then we're going to click on room 3 and group it into the room 3 group. Now to enable blending for these, we select both of them and set the default value to true. While we're here, we'll also go ahead and turn on randomize rotation so we can get randomized rotations. And this is our shader in effect. You can easily add more rooms by selecting our MF noise blend with a different parameter, selecting the lerp, selecting one of the rooms, and selecting the blend with room 3, and then duplicating and renaming it, and also adding it to the correct group. Now I'm not going to show that on screen because it's pretty boring and you should by now understand how to expand this material. A few important things before we go ahead and create a material instance: make sure every time you add a room you change this noise texture offset so it uses a different part of the noise texture. Go wacky, you can use any numbers as long as both of the scalar parameters aren't the same as any other blend here. So of course you'd like to go ahead and create a material instance so you can avoid compilation times and also customize this material to your heart's content. We're going to open up our content browser, we're going to right click on our interior shader, create material instance, and I'm going to go ahead and call this mi underscore apartments. So before we open up this material instance, we're going to go ahead and save our shader. And now if we open up our material instance, you can see we have all the settings we need to blend the rooms together. Here under texture settings, I can select both of these interior mapping X and Y, and I can set both of them to whole numbers, like let's say 15 and 15. And now you can see our rooms are 15 by 15. You can also click on each of the rooms and change the texture they're using. So you can have versions of this building with office buildings in it, or home buildings, or a lot of other type of buildings which you want to create. If we go ahead and enable room 3's blend with room 3 and we disable it, then we have the option to disable blend with room 2. And that's how it goes for every single blend you want to disable. We can also click on any of these noise texture offsets and enable them and change them to whole numbers as well. And let's try 15 by 10 and you can see it's randomized. You can save this if you're happy with the results and you don't have to recompile your shader again. Now that you have a basic understanding of how the shader works, I'm going to add more rooms to it off screen and also set up a demo scene. So see you guys now. Okay, so you might have seen a few effects in that video which we didn't cover. One of the effects I used added the ability to tint the rooms into different colors. This can give the effect of tinted windows. You could do that by taking your last blend and multiplying it with a color. One of the other things I did was bumping up the specularity and lowering the roughness so we have a reflective look to the windows. I also used the noise blend function and mixed it with a few other scalar parameters which are called emission texture offset. I took the end results and multiplied it with my multiply node where I adjusted the tinting of the windows, and then I plugged the final result into the emissive color. For this window pattern, I just took a normal texture and multiplied the texture coordinate to create different amounts of tiling. Then I flattened the normal and added a scalar parameter to adjust the flattening amount, and then I plugged the final result into the normal of our material. If you're wondering, the normal texture is actually the rock basalt, one that's included with the starter content in Unreal Engine. That's all I really added extra. The rest is the same we talked about this entire video. And that's it for the shader. There are a few easy things you can do to improve this shader. You can pack multiple noise textures in one texture through different color channels. This can break up tiling in bigger buildings. Another thing you can do is use more varied furniture. This means you can make a wider variation of rooms, which leads on to my other suggestion. Use multiple material instances with different rooms inside. You can then have a building which has office rooms in it or buildings with apartment rooms. There's so much you can do to improve this shader. But that's it for me. Thanks for watching. If you liked the content, please subscribe. Hit like if you liked the video and dislike if you didn't. My name's Instant Name here, and goodbye everybody.